Picture this. You're sitting in your favorite local cafe. You hop onto their free Wi-Fi to knock out some work. And suddenly, you wonder, is my digital footprint actually safe right now? I mean, who else might be snooping on the data I'm sending across this completely open network? Well, welcome to This Explainer. Today, we're demystifying the exact technology that actively protects your data from those unseen eyes, the virtual private network, or, as we all know it, the VPN. Here's our roadmap for the Explainer today. We're going to break down what the VPN shield actually is, peek inside the encrypted tunnel, see how networking pros deploy this in the real world, compare the protocols they use, and wrap up with how to choose the right strategy. Let's get right into it. First up, the VPN shield and how it protects your digital footprint. Okay, we really have to ground ourselves in this core concept first, because a VPN isn't just some magic app you install and forget about. It's actually a secure encrypted tunnel acting as your ultimate digital shield. At its foundation, a virtual private network creates a highly secure connection between your device's client software and a remote server. When you configure your client and fire up that connection, it essentially cloaks your traffic entirely. Your real IP address, hidden. It gets swapped out for the server's IP. So to the rest of the internet, your traffic looks like it's originating from that server's location rather than, your living room. So why does configuring this actually matter? Well, it bridges a massive gap between personal privacy and heavy-duty enterprise security. For everyday users like us, a VPN hides our browsing habits from ISPs and advertisers, locks down our data on public Wi-Fi, and lets us bypass geo-restrictions by routing through international servers. It can even stop your ISP from intentionally throttling your connection when you're streaming or gaming. But when we look at the industry, it is literally the backbone of secure remote access. It allows network administrators to configure absolutely secure links to internal company resources, no matter where their employees are stationed around the globe. Moving right along, let's take a look inside that encrypted tunnel and follow the journey of a data packet. Think of this 5-step process as a mini story. Instead of your data packet walking down a dangerous public street, it's taking a secret, armored subway line. Step 1, connection establishment. Your VPN client executes a complex cryptographic handshake with the server just to authenticate. Step 2, data encryption. This scrambles all your outgoing traffic into completely unreadable ciphertext. Step 3 is the actual tunneling, where that encrypted payload is redirected to the server to mask your IP. In Step 4, the server decrypts the traffic and forwards it to its final destination, like the website you're trying to load. In Step 5 is the ultimate result, full end-to-end protection, guaranteeing confidentiality, data integrity, and complete anonymity. Now let's shift gears and look at deployment from a networking professional's point of view. What's really fascinating here is how networking professionals actually categorize these deployments. In the enterprise world, you aren't just buying a generic VPN. You are configuring highly specific network gateways to solve very distinct corporate challenges. For example, a remote access VPN is configured specifically for work-from-home employees who need to reach the company internet. But if you need to connect the main headquarters to a branch office across the country, admins will configure a site-to-site VPN right at the router level, seamlessly linking those entire networks. Then you have mobile VPNs, engineered to keep sessions stable when users are roaming, and MPLS VPNs, which offer a highly scalable, provider-managed setup. Though, keep in mind, admins know they have to manually configure end-to-end encryption on those MPLS setups. Next up, we are zooming in on the protocol playbook. These are the underlying technologies that actually build those tunnels. This slide brilliantly illustrates the technological evolution we've seen in networking. On one side, you have PPTP. It's an older protocol. Sure, it's fast because it has very low overhead, but its encryption is completely obsolete. Today, it's really only kept around for legacy system compatibility. On the complete opposite end of the spectrum is WireGuard. This is the modern sports car of protocols. It boasts a tiny, easily auditable codebase and uses state-of-the-art cryptography like ChaCha20. Configuring WireGuard gives you incredibly low latency and blazing fast speeds, making it the undeniable current gold standard. Let's look at 2 more heavy hitters. Networking professionals absolutely love OpenVPN for its robust flexibility. It's open source, heavily vetted by the community, relies on SSL and TLS for secure authentication, and supports massive encryption standards like AES 256. It is, without a doubt, the industry workhorse. But sometimes a network admin needs to get a bit sneaky. They might configure SSTP specifically to slip traffic past really restrictive enterprise firewalls. Why? Because SSTP is a Microsoft protocol that tunnels over TCP port 443. To a firewall, this VPN traffic looks exactly like normal secure web browsing, just standard HTTPS traffic. It's a remarkably clever workaround when standard VPN ports are blocked. Rounding out our protocol playbook, we have tools tailored for very specific scenarios. Take IKV2 paired with IPsec. It completely dominates the mobile space. Why? Because it instantly reconnects your session if you switch from a Wi-Fi network to cellular data. It's seamless. Then there's LTTP/IPsec. While it's definitely more secure than legacy protocols like PPTP, there's a huge catch. It uses double encapsulation. It is literally wrapping your data twice. That heavy configuration causes significant performance overhead, so realistically, it's mostly reserved for cross-platform setups where newer options just aren't available. Finally, let's bring this back to reality and talk about choosing your VPN strategy and balancing those inevitable trade-offs. When you are locking in your VPN strategy, whether you're picking a commercial provider for yourself or configuring a massive enterprise gateway, security has to be your paramount concern. You must demand AES 256 encryption and a strictly enforced, mathematically verifiable no-logs policy. Let's be real. If the provider logs your traffic, the entire privacy benefit goes right out the window. But beyond just security, you have to evaluate the network's performance for low latency, check their geographic server distribution to make sure you can actually bypass restrictions, and ensure they offer seamless cross-device compatibility backed up by solid customer support. However, every single piece of technology has a catch, right? Routing all your encrypted traffic through a remote server will inherently increase your latency. There's no getting around physics. You also face the reality of inconsistent provider quality. A shady provider might actually log and sell your data. Plus, we have to acknowledge that many streaming services and honestly entire countries are actively getting better at detecting and blocking VPN traffic. And for the networking professionals tuning in, you already know that deploying this at an enterprise scale introduces immense configuration complexity and some pretty hefty ongoing subscription costs. It is absolutely a powerful tool, but it's not a zero-friction solution. So I want to leave you with this final thought to chew on next time you connect to a new network. What is your data's journey? Are you actively wrapping your digital life in an encrypted tunnel? Or are you navigating the public internet completely exposed? The choice of how you configure your digital shield is entirely in your hands. Thanks for joining me on this explainer, and remember, always keep questioning how your technology actually works.